Okay, in this part we will work on ideas of number theory, and in total it will be more than 130 ideas and more than 30 homeworks. And we will work on GCD important parts in number theory. In previous parts we worked on algebra and geometry after number theory. In the part after that, we work on combinatorics ideas. And as I said, there are around 40-50 important background ideas or key ideas in combinatorics, algebra, number theory, and geometry. If you want to learn them, feel free to send message my WhatsApp number in the description. Okay, how to apply those ideas and how to work on them. And here we will work on all these problems. Okay. Okay, let's work on ideas in number theory. For this problem, we can use some important ideas. Also, the idea here we use can be used in other problems of, for example, 12A, 12B. And also this problem is from AMC 10B, fall 2021. Try this problem first on your own. Okay, so let's try this problem together. Let's calculate. For example, S1 for Sn. Let me write this. It's 1 times 2 plus 1 times 3 to 1 times n plus 2. The last one is n minus 1 times. Okay, let me tell you an identity. So it will be idea 107. It's an identity. It is a squared. A1 to an whole squared is a1 squared to an squared plus 2a1 a2 a1 a3 to 2an minus 1 an. If we use this identity, we can say it is equal to 1 plus 2 to n whole squared minus 1 squared, 2 squared to n squared over what? Because we have 2 times 1 times 2, 2 times 1 times 3, we divide by 2. Now you can use this identity to solve the problem. And I told you in algebra, in the algebra part, that 1 squared to n squared is what? That's right. 1 to n was what? Was n times n plus 1 over 2 whole square. This part was what? N times n plus 1 times 2n plus 1 over 6 all over 2. Okay, now use this formula for Sn and try to see what's the sum of the 10 least values of n such that Sn is divisible by 3. Okay, try to find out that for which Sn for which n Sn is multiple of 3. Try first on your own. Okay, let's calculate. Here it will be, let's multiply first both numerator and denominator for 12. Let's multiply by 12. 12 times 2, 24. So here for 3, n squared, n plus 1 squared, minus 2 times n plus 1 to n plus 1. And we factor from n times n plus 1. 3n squared plus 3n. And, okay, minus 4n minus 2. Okay? And we divide it by 24. So, it will be what? It will be n times n plus 1 times 3n squared minus n minus 2 over 24. Now we want what? That Sn be multiple of 3. So, because in the denominator we have 3, so we can conclude 9 should divide n times n plus 1 times 3n squared minus n minus 2. Okay. Now we can also use mods. Also, I will tell you important properties of modular. N times n plus 1 times, here can we factorize these? Let's see. 3n n minus 2. If you have plus 1, let's write plus 2 minus 1. Then it will be 3n squared. And 3 minus 3n plus 2n minus n minus 2. So this one should be 0 mod 9. Okay. Now let's rearrange these. It will be n minus 1 times n plus 1 times 3n plus 2 is 0 mod 9. Okay. So n mod 9 can be what? N mod 9 can be 0 or 1 or 2 or 3 or 4 for this one, -4 for 5, -5, -6. This one, -3. Sorry. I said -4 for 5 for 6, -3, -2, -1. Okay, 1, 2, 3, 4, 5, 6, 7, 8, 9. And we will check. So for 0, it will be good. Okay, for 1, it will be good again. For 2, it will be 1. Let's see. 1 times 2 times 3 times 3 times 2, 6 times 2, 8. It is not multiple of 9. For 3, it will be 2 times 3 times 4 times 11. It is not multiple of 9. For 4, it will be 3 times 4 times 5 times 12 plus 2, 14. Okay, so it's not multiple of 9. -5 times -4 times -3 times -12 plus 2, which is -10. Okay, it's not multiple of 9. For -3, it's -4 times -3 times -2. 3 times is -9 plus 2, -7. It's not multiple of 9. -2, -3 times -2 times -1 minus 6 plus 2 minus 4. Because it's not multiple of 3 for -1. It will be -2, -1, -1 plus 1, 0, and next, this is not important. It is good. So we can conclude n is 0 plus minus 1 mod 9. Okay. Now it says n is at least what? It is at least 2. And it says what is the sum of the least 10 values of n such that we have Sn is multiple of 3. So from n2, we know 0, the first one is 9, 9 minus 1, 8, 9, 10, okay? -1, 0, 1. The next one is what? 17, 18, 19. Next one is what? 9 plus 26, 27, 28. And last one is what? 10 least values of n. Okay. 9 plus 26, 35. So sum of them is what? 8 plus 9, 17 plus 10, 27. And here 18 plus 36, 54. And next one, 28 plus this one is 54. 54, 74, 81. Okay, this one 35. So 27 plus 54 is what? 81. 81 plus 81 is what? 162. 162 plus 35 is what? 5 plus 2, 7. 6 plus 3, 9. 197. Okay. And some of the digits 7 plus 9, 16 plus 1, 17. Let's see. It says only some of them, not some of the digits. So 197. So the answer is choice B. Okay, let me tell you some ideas related to divisibilities. Okay, so let me idea 107. Idea 108 in divisibility. A divided B is equivalent that B is AK, which K is integer. 109 we have some properties. For example, A divides 0 always it is the definition, okay? The property is A divides 0 plus minus 1 divides A, and plus minus A divides plus minus A divides minus A, all four possible cases. And if A divides B, B is not 0, we can say absolute value of A less than or equal absolute value of B. If A divides B, we can say plus minus A divides plus minus B, all four possible cases. Let's consider the rest as idea 110. If A divides B, we know AK divides BK. Also, we can say A divides BK. Also, we can say A to the M divides B to the M. Idea 111. If A divides B, A divides C. We can say A divides BC. A divides B plus minus C. Idea 112. If A divides BC and GCD and A and B is 1, we can call it Euclid's lemma. Okay. Then we can conclude A divides C. Okay. And let me tell you about modular 13. If A is congruent to B mod M. We have also some other properties. If you want to know all of them, as I said before, feel free to send message to my WhatsApp number in the description. Definition is M divides A minus B. Idea 114 is like equality. If A is congruent to B and all of them mod M. Then we can conclude A is congruent to C mod M. And okay, next idea 115. If A is congruent to B mod M, then we can say B is also congruent to A mod M. Idea 116. If A is congruent, it is like equality in product, in minus, in plus. When we have addition, subtraction, and multiplication, it is like equality. But for division, we have one more rule, I will tell you. We can say A plus C is congruent to B plus C minus A minus C is congruent to. For all of them, we know mod M, okay? Now we know sum minus, we can product both sides by C, all of them mod M. Idea 117, if A is congruent to B, C is congruent to D mod M, then we can say A minus C is congruent B minus D, A plus C congruent to B plus D, and last one, A times C is congruent to B times D. Idea 118, if A is congruent to B, then A to the N is congruent to B to the N mod M, all of them mod M. And for division, what we have, if A is congruent to B mod M, then we can say, let's do this one. AC is congruent to BC mod M. Then we can divide both sides by C, and it will be what? It will be mod M over GCD of M and C, okay? they are equivalent. And also we can say idea 120. If A is congruent to B mod M, we can multiply all of them by C. AC, in previous part I said AC is congruent to BC mod M, but you can also multiply M by C. Okay, idea 121, if A is congruent to B mod M, and for example X, or for example X divides M, then we can say A is congruent to B mod X. Okay. And I can prove all of them with the definition I've told you. So here we solve this problem. I told you these things in modular and divisibility. Let's solve next one. Okay, this problem was common in AMC 12B and 10B 2022, last AMC. Now we want to apply the rules I told you, the ideas in number theory in spatially modular. Try this problem first on your own. For solving this problem, we should use a small examples, okay? So let's solve some cases. For example, if n is 1, it says add this one. Sn is what? It's x0 plus 2x1 plus 4x2, or 2 squared x2 to 2 to the n minus 1, x to the n, xn minus 1, okay? So, here, for n1, S1 is x0. So it will be 7x0 is congruent to 1 mod 2. So 7 is what mod 2? 1. So x0 is 1 mod 2. And because it says they are either 0 or 1, so here x0 is 1. So we found x0 is what? Now let's try to find x2, x1. So we consider n equals 2. So 7x0 plus 2x1 is congruent to 1 mod 4. 7 mod 4 is negative 1. So negative x0 plus 2x1 is congruent to 1 mod 4. Then we know x0 is 1. So we multiply both sides by negative 1. x0 is 1, 2x1 is congruent to negative 1 mod 4. And if you take 1 to right hand side, 2x1 is congruent to negative 2 mod 4. Then we divide. I told you in division, when we divide by 2, x1 is negative 1. When we divide AC by AC is congruent to BC mod, if we divide by C, then we should divide M by GCD of M and C. GCD of 4 and 2 here is 2. So we can say mod 4 over 2, which is 2. And because x1, xi's are 0 or 1, so x1 is 1. Okay, so we found x0 and x1. Try to do same thing to find, for example, x2, x3, x4, and find the pattern. Okay, try rest on your own. Okay, so let's consider n3. 7 times x0 plus 2x1 plus 4x2 is congruent to 1 mod 8. 7 is negative 1, so we can multiply both sides by negative 1 here. It will be negative 1, 1 plus 2, 3 plus 4x2, and all of them equals mod 8. So 4x2 is congruent to negative 4. Let's write mod 8 here. We divide both sides by 4, so x2 is congruent to negative 1. 8 divided by GCD of 8 and 4, which is 8 divided by 4, which is 2. So x2 is 1. Now let's consider n4. If you consider n4, try n4 and find x3 first on your own. Okay, for n4, we can say 7 times x0, which is 1, plus 2x1 plus 4x2 plus 8x3 is congruent to 1 mod 6. Now we can say, okay, 1 times 3, 38, 48. Let's multiply both sides by 7. Okay, and 49 we know is 1 mod 16. So we can conclude 1 plus 2 plus 4 plus 8x3 is congruent to 7. Then we multiply by 7 because 49 is 1. Now 1 plus 2 plus 4, 7. You can subtract 7. So we can conclude 8x0 is 0 mod 6. Now if we divide both sides by 8, then x0 is 0, x3 is 0 mod 16 over GCD of 16 and 8, which is 8, is 2. So we can conclude x3 is 0. Okay. So here you can continue this approach. X0 is 0. Let me see from x0, yes. X0 is 1, sorry. X0 is 1. X1 is 1. X2 is 1. X3 is 0. So can you guess which xi's are 0? If you check x4, let's also check x4. Consider n equals 5 and try to find x4 first on your own. Okay, so let's calculate this part. It's 7 times 1 plus 2 plus 4 plus 1, 2, 4. 8 times 0 plus 16 times x4 is congruent to 1 mod 32. Okay? Now here, if we multiply both sides by 32, 63. Okay, if we multiply both sides by 9, 63 is negative 1 mod 32. Okay, so here, if we multiply by 9, it will be 63. 63 is negative 1. Again, if we multiply by, let me tell you in 2 steps. We multiply by 9, it will be 63. 1 plus 2, 3 plus 4, 7. Plus 16x4 is congruent to 1. It's congruent to 9 because we multiply by 9. 63 is negative 1. So if we multiply by negative 1, 7 plus 16x4 is congruent to negative 9. Then we take 7 to the right hand side. 16x4 is congruent to negative 16. Mod 32. Now, if we divide both sides by 16, let's see, we will have what? X4 is congruent to negative 1 mod 2. So x4 is 1. Now, here we will see 1. Now you can guess. If it's hard for you to guess, you can keep writing. Only multiples of 3. Our claim is what? Xm is 0 if 3 divides n and n is at least 3. Otherwise, it will be 1. Okay? And you can prove it by induction as homework. Try to prove this. Okay, you can prove it as homework 28 by induction. If you had question, you can send message to my WhatsApp number. Okay, so if you prove this, then here 2019. So the answer will be what then? Calculate the answer. The correct choice. Okay, let's calculate. X 2019, because it is multiple of 3, 2019, sum of digits multiple of 3 is 0. I will tell you the rules for example, modulo 3, modulo 9. So this one is 0. This one is 1. This one is 1. This one is 0. So 4 plus 2, 6, choice A. Okay, let me tell you some rules about divisibilities. Idea 121. Idea 122. For mod 3, if you want to find the remainder of a number mod 3, sum of the digits. I will tell you the reason. Idea 123. For mod 9 also you should use sum of the digits. Why? Because for example, look 5, 4, for example, 7. You say it is 7 plus 4 times 10 plus 5 times 10 squared. We know 10 mod 3 or mod 9 is 1. Okay? Then you say, okay, instead of 10, we can write 1. 1 plus 4 plus 5, sum of the digits. Mod 9 and also mod 3 will be same. For 11 also we will use same thing, but we know 10 is -1 mod 11. So for mod 11 from right you should consider plus minus. Okay, for example, if we have this one, 3, plus from here, plus minus plus minus plus. So if it starts with 6, you say minus. Idea 1 to 5. For example, if you want to consider mod 2 last digit, if we consider also mod 5, mod 10, we can consider last digit. Idea 1 to 6, if you want to consider mod 4, or mod 25, or mod 100. We should consider last 2 digits. These things are important, and I told you these things. Let me tell you something about divisors. 1 to 7, I tell you a problem. For example, suppose 2, 4, 0, 0, 0. I want 3 things. Number of positive divisors. Next one, 1 to 8. Sum of positive divisors. Sum of positive divisors. And idea 1 to 9. Product of positive divisors. Okay. So try to answer these 3 questions first on your own. Okay, so let me tell you, if you want to solve, let's prime factorize this. Each 0 is 2 and 5, so 24 2 cube, 3 zeros, 2, 6, 3 times 5 cube, number of positive divisors. A positive divisor can be 2, 0, 2 to the 1, 2 to the 6, 7 cases, for 3, 2 cases, for 5, because the power is 3, 4 cases. So the power is plus 1, and you should multiply them. 4 times 2, 8 times 7, 56. Sum of positive divisors. The ideas are important, not only the last answer. So here, for 2, you say 1 plus 2 plus 2 squared plus 2 cubed plus 2 to the 4 plus 2 to the 5 plus 2 to the 6 times 1 plus 3 times 1 plus 5 plus 5 squared plus 5 cubed. Okay? And product of positive divisors, you should use rainbow or Gauss idea. Let me write rainbow. It is important idea. Rainbow or Gauss idea. So let me see how many homeworks have I told you. Check. Okay, homework 28. Look for these rules. Homework 29, one AMC problem. I know AMC 2021 that can be solved with this. Homework 30, again, another problem from BMO, British Mathematical Olympiad. For these things, homework 30, homework 31. When you know these things, homework 31 is to one problem of promise related to divisors, ANGN, arithmetic mean, geometric mean. Of positive. That problem is so much good for getting good at casework and also divisors. And here we say what? The first divisor is, for example, 1, the next one 2, the product up to 12,000 times 24,000. If you write it in reverse order, it will be 24,000 times 12,000 times 2 times 1. So if you consider this one P, so it will be what? P squared equals the product of all of them, or rainbow idea is 24,000. So 24,000 to the power of divisors 56. So P is 24,000 to 28. So it will be n to the power of t over 2, which t is number of positive divisors. Here also you can use the formula. You can say the first one is 2 to the 7 minus 1 over 2 minus 1. Let me erase this for times. Here 1 plus 3, 4. Or if you want to write like formula 3 minus 1, 5 to the 4 minus 1, 5 minus 1. You can. Why? Because the identity. I told you in algebra 1 plus r to r to the n is r to the n plus 1 minus 1 r minus 1. Sum of elements of a geometric series. Okay, so I told you these things. Homework 31, homework 32. Also, we have a problem related to sum of positive divisors in AMC. Another problem related to probability and number of positive divisors of AMC. Homework 34, we had a problem 1 plus 1 over 2 plus 1 over 3. The denominators are the denominators that their primes are 2, 3, 5. And some of them is what? It wasn't a problem of AMC. I should search that. Tell you exact problems are what. If you know exact homeworks are what, feel free to send message to my WhatsApp number. Okay. So we worked on this problem. Let's try another problem. Okay, now try this problem of AMC 12B Fall 2021. Also, the idea is useful for AMC 10B or 10A, 10B. So try this problem first on your own. Okay, for this problem, we use casework. Okay, so casework on what? We know GCDs are at least 1. So, here, we consider the maximum one is 7, cannot be greater than 7711 for GCDs. Okay, we don't need to calculate permutations because at the end we want to find a squared plus b squared plus c squared is symmetric with respect to ABC. 711, 621, and 5 here, 3, 4. It's 3, 1, 5, 2, 2. If the maximum one is 4, then 4, and the sum is what? The sum is 9. So 5, 4, 4, 1, 4, 2, 3. Okay. Now, if the maximum one is 3, 3, 3, 3. Okay, let's consider the cases that are not possible. When we have 2, 2 means what here? Means B and C are multiple of 2. Next one, C and E multiple of 2. So we can conclude A and B are multiple of 2. So this one also should be even. So it's not possible. If 2 of them are multiple of something, third one also should be multiple of that. Here 4. When it is 4, we know A and B, both of them should be multiple of 4 because GCD is 4. Here B and C are multiple of 4, so C multiple of 4 because of here, A multiple of 4 because of here, so this GCD should be multiple of 4. Okay, and it cannot be 1. Let's consider this case, 4, 2. These two things are even, last one should be even. So 1, 2, 3, 4 cases are left that we should check. So for the first one, A and B are multiple of 7. So 7A prime plus 7B prime plus C should be equal to 23. Okay, now we can conclude 7A prime plus B prime plus C 23. So one case, this one cannot be 4. It can be 3 or 2. Okay, so when it is 3, let's consider these two cases. So when it is 3, one of them 1, one of them 2, without loss of generality, it is 1, 2. If it is 2, 1, 1. Okay, so for this case, A7, B7, and here is 21, 7 times 3, C is 2. So, and we will see, okay, GCD of C and A and C and B will be 1 because 1, 7, GCD is 1. If there are 1, A7, oh, sorry. Here we said B prime is 2, B is 14. Okay, and C is 2. But GCD of B and C won't be 1, so this case is bad. Here, A7, B7, 7 times 2, 14, 6, 3, 9, C is 9. So this case is good. Okay, so one good case is this one. 7, 7, 14 plus 9, 23. The sum and GCD of A and B is 7 plus 1 plus 1 is 9. Now let's check this case. GCD of A and B is 6. So A is 6A prime, B is 6B prime. And we know GCD of B. Here it's not possible. Why? Because here it is 6, here it is 2. So even. So this one should be even. Okay. Now try to check these two cases on your own. First on your own, then we will try together, and the choices are what? It says what is the sum of all possible distinct values of this. Okay, some of them. So here it will be what in this case? A squared B squared plus C squared. In this case, it's 49 plus 49 plus 81. So 49 plus 49 is 96, 98 plus 81. So it will be 9, 179, 1 plus 8, 9, and 9 plus 8, 70. Okay, because this less than these choices, probably we have 100%. We have more answers, so try to check these two cases first on your own. if we concept 531, we know b is here and here. So b is multiple of 5 and 3. So b is multiple of 15. So 15b prime. For example, b1, a is what? A is multiple of 5. So 5a1. C is only in second one and third one. So C is multiple of 3. So 3c1 equal to 23. b1, because it says they are positive integers, b1 can only be 1, okay? And then 8 will be left. For 8, again, we will see, okay, the only possible case is 1, 1, 1. So A is 5, B is 15, C is 3. Okay, let's check some of them is 23, GCD of A and B is 5, GCD of B and C is 3, GCD of A and C is 1. Okay, so for this case, A squared plus B squared plus C squared, 225 plus 225 plus 9, which is 259. Okay, this one. And now, last case, 333. Try this last case again first on your own. Now let's consider this case here. It will be 3, for example, A2. We say A2 to not use same variable. 3A2 plus 3B2 plus 3C2, because GCDs are 3, equals what? 23. So as you can see, it's not possible. So 259 plus 179. 9 plus 9, 18. We have 1. 6 plus 17, 7, 13. We have 1. And this one will be 4. So the answer will be choice B. Okay, so we've considered up to which idea here. We've used casework, GCDs, and sometimes you should consider GCD. This idea useful. 131, consider GCD in many problems. And for example, one thing is what? Idea 132. If AB is x squared and GCD of A and B is 1, then we can go. We had similar problem in AMC 2022. Then we can say A is, for example, perfect square, B is perfect square. The problem in AMC 2022 132, idea 133. If AB equals px squared, which p is prime, and GCD of A and B is 1, then we can say one of them, for example, A, without loss of generality. One of them is px1 squared, one of them is x2 squared perfect square. And how many homeworks did we have? Homework 34, homework 35. Homework 35, an AMC problem. AMC 2022, 12. 2022, I should search. It was related to Tn, triangular numbers, n times n plus 1 over 2. That equals to a perfect square. Equals to perfect square. And it says for some T1, T2, T3, we wanted to find T4. Okay, in that problem, we should use this idea. Okay, if you want to learn, I told you 133 ideas. If you want to learn other ideas in number theory and other topics, as I said before, send message to my WhatsApp number in the description.